Hey guys, here's an example of how to calculate the specific heat of an unknown metal, like we did in our specific heat lab. Here's an example of brass in water. We're going to use a 70-gram piece of brass at 100 degrees Celsius and place it in 155 grams of water at 0 Celsius. The inner cup of the calorimeter has a mass of 3.51 grams. It's made of styrofoam. Specific heat of styrofoam is 1300 joules per kilogram Kelvin or Celsius. The stirring rod made of nylon has a specific heat of about 1310 joules per kilogram Kelvin and a mass of 1.2 grams. The system reaches equilibrium at 9 degrees Celsius. What is the experimental value for the specific heat of the brass? If the system is at equilibrium, there is no longer any heat transferred, so that means all of the energy that was gained by the water, the stirring rod, and the styrofoam calorimeter is equal to the heat lost by the sample. So if this were 0 equals QA plus QB plus QC plus QD, which would be the metal, we take QD and add it over here, subtract it over here, distribute that negative sign, and that's why these two terms are flipped. So we have initial temperature minus final temperature, okay, because we moved it to the other side of the equation and distributed that negative sign. Anyway, let's substitute now. The C value is what we are looking for. We want to find the specific heat of our sample of brass. We substitute its mass and its change in temperature. And then we have the heat absorbed by the coffee cup calorimeter. So its mass, its specific heat, and its temperature change, plus the heat transferred to the water. So you have the mass of the water, specific heat of water, temperature change of water, plus the heat transferred to the nylon stirring rod. We have a very small amount because the stirring rod has very small mass, but there we go. So we're going to add all of this up and we get a sum of 5,894 joules. And we can multiply this 0.070 times 100 minus 9, which is 91 degree temperature change, and we get 6.37 times the specific heat of brass. So we're going to divide this under both sides. So 5894.685 divided by 6.37 gives me a C value of 925 joules per kilogram Kelvin. We will compare that to the book value of brass, which is 380. We have a huge percent error here, 144%. Why? Well, because I made up this problem and I made up the final temperature. But that is how you solve for the specific heat using this algebra. All right, good luck. Happy physicsing.